So today, what we're going to do is we're going to start section 3.4, acceleration. To change the velocity of something, we can, 1, change the speed. Change the direction. Or change both. That's what I just did. So I did both direction and a change in speed. Now, how do you do this in a car? Well, there's the gas pedal, or accelerator, which can cause you to speed up or slow down. There is the steering wheel, change direction, and you have the brakes, which allows you to slow down. An acceleration occurs whenever there is a change in velocity. And the way we represent velocity, you might recall, is with a V. And if it's a change, we use the Greek letter delta. If we divide that change in velocity by the time interval, we get what is known as acceleration. And this was first defined by Galileo. So A stands for acceleration. Delta stands for change. V we use for velocity or speed. If we put a bar on top of it, that stands for average velocity or speed. Recall the difference between velocity and speed, right? Velocity is speed with direction. Velocity is defined as the displacement of an object over the time interval, whereas speed is defined as simply distance over time. So velocity is a little bit more complicated than speed. So for example, suppose you have an airplane that's flying in a circle like this, and let's say you want to figure out its average speed as it goes once around the circle. Let's say the distance going around the circle turns out to be, let's say 50 meters. And let's say this takes 2 seconds to go around once, 1001, 1002, something like that. What would its average speed be? Wow, I'm a little bit dizzy. What would its average speed be? Wouldn't it be 25 meters per second? You just take 50 meters, that's the circumference of the circle it traveled in, divided by the time, 2 seconds, 25 meters per second. But how about the average velocity? Well, since the plane ended up where it started from in that 2-second period, wouldn't the displacement be 0? So the average velocity would be 0. Okay, so let's return to acceleration. Let's say we have a car that starts from rest and reaches a speed of 20 meters per second in a time of 5 seconds. So it starts from rest and it reaches a speed of 20 meters per second in 5 seconds. Okay, so its speed is increasing over 5 seconds, and it's traveling at 20 meters per second at the end of that 5-second time interval. What is the car's acceleration? All right, so let me draw the car. So it starts out from rest. So we're going to say original speed, VO, equals 0, and it ends up going 20 meters per second in a time interval of 5 seconds. What is its acceleration? Well, acceleration is equal to the change in the velocity over the change in time. Well, our speed is to the right, so it's a positive. So the change in speed is going to be the same as the change in velocity in this case. So to find the change, we take the final 20 minus the original 0 divided by the time interval 5. So we get 4 meters per second per second. And that's because the unit of time is the second, the unit of speed or velocity is the meter per second. So you have a meter per second per second. So what that means that in 1 second, the car would be traveling at 4 meters per second. After 2 seconds, 8 meters per second. After 3 seconds, 12 meters per second. After 4 seconds, 16 meters per second. And after 5 seconds, 20 meters per second. In other words, for each second of travel, its speed increases by 4 meters per second. Let's take a look at another example. Suppose the car is driving along at 20 meters per second and the driver slams on the brakes. And let's say that in 1 second, the car stops. So it's coming along, slams on the brakes, and the car stops. What is the car's acceleration? Now you might think of this as a deceleration, right? Because it's slowing down. So here we have an original speed of 20 meters per second and a final speed of 0 meters per second. And this occurs in 1 second time interval. So the acceleration A is equal to delta V, delta T. So now the final speed is 0, and the original speed is 20 meters per second. Divide that by the time, 1 second, and we get negative 20 meters per second per second. So in other words, each second, the car speed decreases by 20 meters per second. So that's why in 1 second, it's at rest.